Hi, everyone. How was lunch? Was it good? Perfect. All right. It's a small crowd today, but I think that's okay because the topic is very specific, right? So we're going to be talking about the proposal to bring decorators to JavaScript. A few words about me. I'm an engineer at this startup called Sutro, where we use AI to enable everyone to very easily build applications just by describing what they want. I'm the co-founder of a company called Living Room Events. I've been in web development for quite some time now, and I live in Switzerland. If you want to connect with me, feel free to do so on X or on LinkedIn. And yeah, so before I talk about the decorators proposal, I want to take a quick detour, and I want to talk about the question: how do new features get added to the language of JavaScript? You see, the standard for the JavaScript language is called ECMAScript, and ECMAScript 1, the very first version, was released together with Netscape Navigator back in '97. It was created apparently in just like 10 days. The name JavaScript back then was like a marketing thing because Java was really the way to go. And then in the next 2 years, later versions followed. We had ES2, we had ES3, and those just like enabled to like get some interactivity on a website. Now, after that, for a long time, they started working on ES4, but that kind of went nowhere. And instead, we got ES5 in 2009. And if you think about it, that's not even that long ago, right? So ES5 kind of made the modern web possible. It introduced features like the XML HTTP request, which enabled us to use AJAX and like asynchronous requests. And for a very long time, ES5 was the way we built web applications. Now, with ES5, JavaScript got more popular. More developers started using it, and yeah, there were talks about we need to make this language a bit more modern, a bit more approachable even. And in 2015, ES6 was released after quite a few years of work that went into this. ES6 was also co-titled ES 2015 because from this point on in time, we had those yearly releases. We have like a new ECMAScript version every year. And well, ES6 or ES 2015 introduced quite a lot of like more modern language features, such as classes. I think we had promises then as well. And yeah, the idea was to be more welcoming for like developers coming from other languages as well. So those are the versions, like ECMAScript, that's the standard that defines JavaScript, but who decides what gets into these versions? Well, that's actually this technical committee, TC39. It's part of the ECMA standards body. And it's basically just a group of JavaScript developers, implementers, so many browser vendors as well, academics and researchers, and together with the community, they are collaborating to evolve the language of JavaScript. Now, for a new feature to be added to the language, there needs to be a proposal. And you can actually check this out. There's a GitHub repo from TC39, and you can see all the active proposals. If someone has an idea, they first present it as one of those meetings, and if enough people say that's something that should be pursued, then a proposal is created. It starts at stage 0 and it goes all the way to stage 4. Stage 4 is when it's implemented in JavaScript engines, basically. And yeah, we as JavaScript developers should actually, it would be really good if we were part of this. So we can take a look at what proposals are out there, and we can actively discuss it because they need the feedback from actual developers as well. So for Decorators, it was a bit special because this was first proposed in 2014. That was when they were working on ES6. This was when classes were introduced. So it was first proposed then, but there was just lots and lots of delay due to very different interests. It was apparently very hard to get everyone on the same page about what Decorators should be able to do. And during the different stages of the proposal, it changed a lot of like what Decorators are capable of and what not. But right now they are in stage 3. That means like their text is basically finalized. There's implementations pending. So there's like an official transform for Babel. But there's also browser vendors working on implementing Decorators in their JavaScript engines. And while I don't know when it's going to land, I'm thinking that we're probably going to see the release of Decorators next year, which would be like kind of cool because then it's exactly 10 years since the proposal was started. Now, when we talk about all of those new features, especially since ES6, then we also have to say that like not everyone is a fan of those. So for example, do you know this guy? Okay, that's Douglas Crockford. He's the author of the JSON specification. He's also kind of like the godfather of JavaScript. He wrote multiple books on the topic. I think his most prominent book was like JavaScript, the good part. And in a talk in 2014, so that was when they were working on ES6, he said, well, there are a few features in ES6 that we know are going to be bad, and the worst is class. So he's not a fan of classes. Well, first of all, why is that? Well, if we take a look at a class in JavaScript, how we can write it today, then we have to say that this was possible in ES5 too. It just looked different. Because we would write it like this, right? It's a function. A class is basically a function. And the implementation on the left side, it boils down to the same thing. It's still underneath, it's a function. It's a special function, basically. And we still have this prototypical inheritance, which makes JavaScript so special. And in fact, we could even say that Decorators, how they are proposed in this new proposal, we could do something like that too, of course. It's just a function that wraps another function, basically. So all of this was possible before, which means that class, as well as Decorators, as well as other new features as well, are basically just syntax sugar. And while I think it's still important for us developers to know like what's happening underneath, that we still should learn about prototypical inheritance and how like classes inherently work in JavaScript, I still think that syntax sugar is actually a very good thing because it leads to more readable code. If you compare the two, I mean, the one on the right is actually a bit, it's fewer lines of code, but I think the one on the left is just more readable, right? And it also helps a lot to developers coming from other languages because the web is getting more and more important. And there's always going to be like those developers, like new JavaScript developers. And for them, it's just way easier to understand like what's actually happening. Now, you can also say that decorators are not a new thing. There are other languages that have decorators, such as Java or Python, C#, other languages as well. But even the JavaScript ecosystem had decorators for quite some while now. TypeScript implemented them a while ago already. They were, most of the time, they were hidden behind the experimental decorators feature flag. And there was a bubble transform that we could use to make use of decorators for a while now too. And there's frameworks out there, JavaScript frameworks or TypeScript frameworks that make very heavy use of decorators already. I guess the most prominent one which would probably be Angular. And yeah, Angular uses like decorators everywhere. So this is how you could transform like a simple class into like a UI component. And yeah, they use it. They use it very heavily. They use it for other things as well. Another good example would be NestJS. So NestJS is a backend framework. It's heavily inspired by Angular, and in there we could use this to build our controllers, right? To build our routes. So this could be like our cat controller. We say add controllers to say this is on /cats should be available. We can use authentication. It uses decorators for everything, and it works quite well. So let's take a more detailed look at the decorators proposal and what it seeks to add to the language of JavaScript. So when we talk about application code, or when we are working on an application ourselves, then usually we can make like the distinction of programming versus metaprogramming. And so programming we can define as the code rewrite that processes user data. So this is going to be our application logic, or our business logic, basically. Metaprogramming would be the code we write that processes code that processes user data. So usually we wouldn't use decorators to write like business logic, but we would write decorators to use throughout our application. And with this proposal, decorators can be applied to classes, to class fields, class methods, class accessors, and they are also introducing a new class property called class auto accessors. So as you can see right now, we can only use decorators with classes, but as soon as this landed in JavaScript or in ECMAScript, the authors of this proposal already like prepared follow-up proposals to add this to other things as well, just to like constants or to functions, so that we could use this in like outside of classes as well. But let's take a better look at classes and the class members that we currently have. So the top one is going to be the public field. That's just a field that's accessible from outside, can be written, can be read. Then we have the private field. This can like only directly be read from inside of the class, but you can specify getters and setters. Those are accessors, in which you have like an implementation how you choose to share this private data, basically. So the new thing is going to be this, the accessors. So what the accessor does is it basically does all of those three things at once. So if we add the accessor to the private field, then it will create like the private field for us, and it will automatically generate like a getter and setter pair for this field. If we use it like this, then it's going to be private, meaning the getter and setter pair is private too. So auto accessors are needed for decorators because decorators can only influence like the values that fields are initialized with. But with auto accessors, they can like completely replace the whole thing, including the accessors. So this is how decorators can look like. In here, they are applied first to a class, but also to a class method. And from the invocation, it's going to be the outer first and then to the innermost. So in here, we have the first, which is going to be invocated first, and then we have the second one. Decorators have three primary capabilities. So they can change or replace the value that they are decorating with the matching value that has the same semantics. Meaning, if we decorate a public field, then we can only replace it with a public field. We can also provide access to the decorated value via the accessor functions, which can then be shared. That's actually very cool because you could use this for like private fields as well. And we can process the decorated entity after it was initialized. There is also a related proposal. In the beginning, that was just one big proposal, but then when the text changed, they needed to create like this additional proposal to add metadata to decorators. It extends the decorator proposal. It doesn't stand on its own. But it's also in stage 3. Hopefully it's going to land next year too. And with the decorator metadata, you will have the ability to save metadata inside of decorators. So I'm going to be showing a few examples now how we can use or how we can make use of decorators. So the first example is going to be a web component. We want to create a decorator to, well, who of you has already worked with web components? Okay, a few. That's cool. I don't have much experience, but I don't think it's needed for this example. So we can write the web components basically like this. We have like the class myElement. It's going to be a new web component. It extends the HTML element. And now to actually use this inside of our application, inside of our DOM, we have to register this new component. And instead of doing all of this manually, we want to introduce this new decorator called custom element, where we can specify the name of the element, and then, well, hope that it's automatically being like registered and we can use it everywhere. How could this look like? How would the implementation of this look like? Okay, so a decorator is basically just a function. And because we specified a parameter, so the name of the element, we have to create like this wrapper function in which we receive the name as a parameter, and then we have to return this function basically, which receives 2 parameters. The first one being the value that is decorating, and the second one is a context. We have a few possibilities inside this context, a few things that we can do. Now in here, we're going to use the add initializer. Add initializer we can use to register a callback function that is being run after the value has been, the decorated entity has been initialized. So in this case, this is going to be the class. So we add this initializer callback function, and then we just say custom elements dot define. That's how you define a new web component to use inside of your application. Custom elements dot define, then the name, and this in this case refers to the newly created class. So that's kind of important that at initializer we don't use the arrow functions because we wouldn't get the context, but instead we use like traditional functions, and this is going to be the initialized element or the initialized entity. And that's it. Actually, it's quite simple, I think. The next example is going to be a log decorator. We want to be able, if we have a class with something that does like something very complex and time-consuming, like returning a string, we want to be able to decorate this with the @log decorator. And then what we want to happen basically is that every time this method is called, it writes to a log somewhere, and it writes how much time it takes and so on. So this is how we could implement this. Now, because in here I'm not taking like a parameter to the decorator, I can just return the function directly. So here again, we receive the value. That's the decorated entity. And we have the context. And from the context, we want two things are interesting to us. That's the kind, and that's the name. So kind is just like what we've seen on the slide before, like what kind of entity we are decorating. And because we only want to enable this for methods, first of all, we do this check if kind is a method, and only then are we doing anything. Now, in here, we are actually replacing the decorated entity. We're replacing it with a new function. I can thus return function. It takes a variable amount of arguments, and then what we do instead when this method has been called is we take the time it was started. Then we log, we say executing name. Name is going to be the name of the decorated entity. So in this case, the method name with parameters. And then we display like all the parameters that were passed to this method. Then we call the original function, which is just going to be value there. We get the return value. Then we log, okay, it's done now. It took so and so many milliseconds, and then we return the original value. So as you can see, we are replacing the whole method basically, but the semantics stay the same. It still takes like the same amount of parameters, and for the developer, it doesn't really make a difference if it was decorated or not. And so if we use this now, we say instance.say hello max, then we will get the log. It says executing say hello with parameters max, and then it says done, took 0 milliseconds. Very, very efficient method. And that's it. So I feel like this log is not really, if we like log all of our application logs into the same file, then just say hello doesn't really mean that much, right? Because it belongs to a class. Now, unfortunately, in the method decorator, we have no reference to the class itself. We only have a reference to the decorated entity. This changed. It was different in previous versions of the proposals, but it would be really cool if we could add the class name in there as well. So for that, we could introduce like a new decorator. Either it could be the same, we could use the log and then like make the differentiation. Is it a class or is it a method? But yeah, for reasons of simplicity, I'm just adding a new decorator now, which I call log config. And what I'm doing here is now that it takes one parameter, which is going to be the log level, which we can define for like the whole class. It could be like info, it could be warning, it could be error. So it could be possible to define this on like this class level. So to implement this decorator now, we can make use of metadata. So we still have like the same function, right? We have the decorated entity, and then from context, we have the name, that's the class name, and then we have metadata. Metadata, that's this separate proposal. And the metadata gets inherited to other fields inside this class as well. So what we can do is we say for this metadata, we say log level is log level and class name is the name of the decorated entity here, which is the class name. And now we can rewrite our log decorator basically, and we're going to read the metadata, and in here we say, okay, we prefix this with metadata.className, and then we have here the log level. And yeah, when we execute this, then we see the same output as before, but we have the class name in there, we have the log level in there, and that's it. Yeah, I think that's kind of cool. So with metadata, we have like lots of possibilities to do those kinds. We can also like save metadata that we're then gonna be using inside of the like decorated method as well, which is kind of nice. The third and last example is going to be injectable. So the idea being we want to implement our very own dependency injection. This is something that like frameworks like Nest or Angular already have. They implement this in the same way. I'm going to show you how we can do that ourselves. It's not that difficult, actually. So how could this look like? So for example, we could have like this class DB adapter. The DB adapter is going to be responsible for all things communication with our database. And we want to be able to make use of this throughout our application, throughout our controllers, wherever we need it, basically. And what we want to be able is to add this injectable decorator. And here's how we could implement this. So first of all, we would have to like keep a map of all the injectables, like all of the classes that we want to be able to inject somewhere else. And then the decorator is actually quite simple. We're going to use the add initializer again. That's the callback function that runs after the decorated entity has been initialized. And what we do here is we add this callback function. Now here again, very important, we're going to be using like classical functions, not arrow functions. And we say injectables.set. The key is going to be the name of the class. And then we create a new instance of this, because this, in this case, refers to the class. So in here, we create the instance and we add it to a map. Now, if we want to be able to use this somewhere, so this could be like our application controller, we have some kind of logic in there. We might have a method called find users, and in there, we want to make use of this DB adapter. We want to create a query that that returns us all the users from the database, right? So what we can do is we add a new class field called dbAdapter. And then we want to be able to inject basically our class instance from before, so it's available on dbAdapter. And then we want to be able to just do this.dbAdapter.query. How could this look like, this inject decorator? Well, first of all, we need this wrapper function, which takes the name. That's going to be the name of the class. Then we return this decorator function, which takes the value. And in here, we want to replace or actually initialize the value with the instance. So what we have to do actually to replace the value, we have to return a new function that is being called, which then returns our class instance, like from this injectables map that we created before. And that's it. That's how dependency injection can be implemented using decorators. Quite simple. So those were my examples. I just want to say that me personally, I am very excited about this proposal, or this like new feature to be added to the language. I might have to add, by the way, that I'm not involved with this proposal in any way. I didn't do any work on it. I just, yeah, actually, I only learned about this like 1.5 years ago when I was looking to, for like a clever way to implement something, and I found this proposal and I thought it's like, that's really cool. That will actually make a lot of cool APIs possible. But as I said, you can use decorators today. You can use them in TypeScript with the experimental decorators flag, which is then based on the newest version of the proposal. You can also use the Babel plugin to use decorators. And yeah, I think we're going to be seeing them very soon in browsers and JavaScript engines. If you want to do some more reading, there's a few very good resources, I think. So this is the text of the official proposal. There's the related proposal about the decorator metadata. This is a very in-depth article by Dr. Axel Rauschmeier, where he describes JavaScript, where he describes the JavaScript decorators as well as metadata and everything beyond, basically. Here's the introduction about decorators in TypeScript 5, because they are now based on the stage 3 proposal. And here is the official Babel plugin. Now Babel also has like this online kind of playground where you can just like try out those new features. And yeah, that's it. Thank you very much. Do you have any questions? Yes. Oh, that's a good question. So the question was about how the TypeScript implementation differs from the new JavaScript proposal. So the thing is that there were decorators for quite a long time in TypeScript now. They were hidden behind this flag. But in previous versions of TypeScript, those decorators were based on earlier versions of the proposal. And with, I think, yeah, with TypeScript 5, they are based on the stage 3 proposal. And actually a lot has changed in the proposal since then. So I would say, yeah, it's different how they work now. If you want to upgrade them, then that could require some effort, I think. Yeah. Actually, I didn't show much TypeScript now. I was really focusing on like the vanilla JavaScript implementation of Decorators. Are there any more questions? Yes. So the question was why the proposal took so long. Yeah, that's a very good question. Because when it was first started or first proposed in 2014, I think like the process was not the same as it is now. And it was an idea back then. Initially, they wanted to release it together with classes, but that didn't happen. And yeah, I think they have like a very detailed, a few detailed reasons on like linked at the proposal itself, why it took so long. But mainly it was like there were so many like people already using Decorators with TypeScript, with AdScript. It was which Angular used back then. And they had like very different implementations. They worked different. And yeah, apparently it was just very hard to get everyone on the same page because everyone just wanted something different. And yeah, now it's kind of a compromise, and this additional proposal was needed. But yeah, usually the proposals don't take that long.